good afternoon. All right, so good afternoon to everyone. A very good afternoon to all of you, my dear students. A very good afternoon to all of you. So, guys, my name is Dr. Umashankar and I am your physics educator. And in this session, we are going to begin with a very important concept that is of projectile motion. Okay, so in this session, we shall be talking about the projectile motion. Okay, now please understand this. Okay. So this is basically a topic of motion in two dimension, that is motion in a plane. Okay, so this is motion in a plane, right? Or you can say motion in two dimension. Okay, motion in two dimension. So guys, as we know that we have already completed the vectors. Okay, that is a part of this motion in two dimension or motion in a plane topic. Okay, so now we are going to see that how we can use the concept that we have learned in motion in a straight line and the vectors to understand this projectile motion. Okay, so basically in the last session I have done this motion under constant gravity. Okay, motion under gravity. Okay, so this projectile motion is somewhat the application to it. Hello Shrisai, welcome back. So this projectile motion is nothing but application of motion under gravity. Okay, motion under gravity. So that is why I came up with this session so that you can see some more use of motion under gravity. All right. Okay. Now, what is a projectile motion? So when I say a projectile motion, something must be coming to your mind, right? So what is coming? What shall come in our mind? So see, projectile motion you must be thinking is something like this. So if like suppose a ball is thrown from one, so like we do in our schools now, we play catching of the ball. So from one place, a student is throwing a ball and the student is catching it. It's some sort of a projectile motion. So what is the meaning of projectile motion? So if something is following the path of like this, okay, if some motion is like this, okay, now this is the initial position, this is the final position. So if some motion is following this kind of a path, we call it a projectile motion. Okay, that it happens to have a projectile like this, a trajectory like this, a path like this, whatever word you can use here, right? Now basically what happens, like from this initial position, if something is thrown, let's suppose a ball is thrown like this, so basically it may have some initial velocity, and obviously its initial velocity would be like this. Okay, its initial velocity would be like this, right? Okay, now obviously, so let's suppose initially it is thrown with an angle of theta. It has been thrown with an angle of theta. Now this is its velocity. Now at every point, do you realize in this case that we have a velocity in the horizontal direction and we have a velocity in the vertical direction? So I'll keep it very quick. Okay, I'll cover as much as we can in this session. Then we'll come up with more sessions on projectile motion. Yeah, sure. I'll speed up. That is the plan, right? So after the vector is completed, we can obviously speed up, right? So now, but we have to understand the concepts also. Okay. So now, do you realize that in this projectile motion, if you see the velocity of any point, okay, on this path, there will be two components. One component will be horizontal, one component will be vertical. So that is why it is called upon as a motion in 2D. It comes under motion in 2D topic. Why it comes under motion in 2D topic, beta? Because we have both x and y motion together. Okay, x and y motion together. Do you agree with it? Yes or no? Okay. Okay. So here, what is this theta? Theta is known as the angle of projection, and see component, we know that what is the component of any vector in the direction of theta is with cos theta, and perpendicular to that it is sin theta. So this is what we call as the angle of projection. Okay, Now, basically, when we say a motion in two dimension, basically we must deal it in two directions first. Like we have to see it in X and we have to see it in Y. Now, please understand this. Let me make it so. See, very, very simple. This is extremely simple. If you understand the motion under constant gravity, this is just, a little bit value addition in two dimension. Now, this is your U initially, this is your theta. So we can call it U cos theta and we can call it U sin theta. Okay. Now, all we have to do is understand this equation. Hello, Bima. All we have to do is understanding this equation in X direction and Y direction. Okay. Because it happens to be in both direction together. Now, something is moving like this. So it is displacing in both X and Y direction, right? Now, if I ask you, what is the initial velocity in X direction? Now, we have to break down this motion basically in X and Y direction. Now, if I ask you that what is the initial velocity in X direction? So you would say, sir, obviously the initial velocity is going to be U cos theta. What is the initial velocity in y direction? The initial velocity in y direction is u sine theta, right? It's u sine theta. Okay. Okay. Now please understand this. So as soon as this motion, so proceed. Let's suppose within some time we'll reach this point. Okay. Within some time it will be this point. Within some time it will be this point. It will be this point. It will be this point. So we need to realize a few things. What is the few things that we need to realize? Now, now something is following a path like this. So will it have any acceleration in x direction? No, sir. Gravity doesn't work in x direction. Gravity doesn't work in x direction, right? What I'm trying to tell you here, let's suppose that the motion begins. Let's suppose the motion begins at a velocity of, let's say some time. So let's suppose its vertical component is 3 meter per second, and let's suppose its horizontal component is 4 meter per second. Now with time, it will follow this trajectory. It will reach this point, this point, this point, this point, this point. Now will any point have any acceleration in x direction? No, sir. Gravitational, and we are neglecting all this air resistance, air friction, all these things are neglected, right? All these things are basically neglected. Okay. Now when these things are neglected, we have acceleration only in y direction. There is no acceleration in x direction. Now what does that mean? So does it mean that wherever you see you will find the same velocity, in x direction? The x direction velocity is not going to change because it is having no acceleration in x direction, right? Huh. So it simply means that throughout this motion, this will remain constant. Okay, throughout the motion, this will remain constant. So since we can write this, since no acceleration in x direction, since no acceleration in x direction, velocity in x remain constant. Velocity in x remain constant. But can we say the same thing in the y direction? No, sir, we cannot say so, because in y direction, obviously, there will be some acceleration due to gravity. There will be some acceleration due to gravity, and it is always be negative, because what we have learned, the in our sign convention that we are following, from some reference, if any vector is downward, we'll be considering it as negative. So acceleration is always negative here. So we can say that AY, acceleration in y direction, is minus g. Acceleration in y direction minus g. So in the case of projectile motion, acceleration, can we say acceleration only acts in y direction? Acceleration only acts in y direction. Yes, sir, we can say so. Okay. Now, if we try to realize that what is going to be the effect of this this acceleration on this velocity, okay, and this is always going to be the case. Okay. Now, please understand this. So, with time, what is going to happen? So, acceleration, so initial, so see, it is moving in the path like this. So, initial, the velocity in the y direction, let's suppose, is 3. So as soon as it moves further, this velocity will have some decrease. After some time, it will become 2.5, then it will become, say, 1.5. And at some point, it is going to become zero because of this acceleration in the upward direction. Do you agree or not? Do you agree or not? Right? Yes or no? Okay. Now, please understand this. So, from this discussion, what we can have, what we can have. So, if we talk about the velocity in y direction, the first thing, velocity in x direction remains constant. Velocity in x direction remain constant. Okay, it is going to, yes, remain constant. Okay, and what will happen to the velocity in y direction? Please observe. So it follows a path like this. Okay, now, so we have done the motion in, under gravity. So see, gravitational acceleration is acting downward. So what is going to happen? At some point, the vertical velocity is going to become zero. But this point, so when vertical component is going to become zero, it cannot move any further in height. So wherever it is going to become zero, that will be the maximum height that it can reach, isn't it? Can it reach any height further? Okay, please understand this. So the projectile motion begins, the velocity in x direction remain constant. So that means it obviously always move ahead in x direction. But in y direction, what happens? Due to this acceleration, at some point, this velocity will become zero, and at that point, it reaches the maximum height. This is going to be the maximum height, of course. And afterwards, what is going to happen? Afterwards, what is going to happen? So, afterwards, this particle or this component will have a downward velocity, and it will increase, it will further increase, it will further increase. And at this point, this is going to become 3 meter per second due to conservation of energy. Yeah, right? Okay, and at each of the point, it will have the same constant horizontal velocity. Okay, okay, is it clear? So, what is happening to the velocity in y direction? Okay, so velocity in y direction first decreases, it will first decreases, and when it becomes zero, and when it becomes zero, when it becomes zero, okay, the particle or the ball or anything the particle will reach maximum height. Okay, afterwards, afterwards, the velocity the velocity in y direction increases again in opposite direction. It increases again in opposite direction. I hope it is clear to everyone, right? So this is what is happening. This is the motion. I think this is going to be have clarity in your mind that what is happening in x and what is happening in y. Right? In x, the velocity remains constant, acceleration is zero. Right? In y, the velocity firstly decreases due to the influence of the downward acceleration. It reaches zero mark. At the zero mark, that is the point where the motion reaches the maximum height. From there, it will have the velocity but in opposite direction. And at the point when it came back to the ground, what is going to happen? It is going to have the same velocity which it is thrown, because we have neglected the resistance of the air and everything. So we can use the conservation of energy and we'll have this, right? Okay. Now there are a few terms. Bima, is it clear to you, Beta, also how this motion is going to happen? Okay. Now, see, quickly we are going to see some terms related to it. So this is nothing but you see application of the motion under constant gravity. So there are some important terms. So this is the basic projectile motion where projectile from ground reaches to the ground. There are other cases as well. We'll come up for that. But in this session, I'll be going to tell you about this. right? Very good, Bima. Okay. Now please understand this. So there are a few terms that is very, very important. Okay. So, and then we'll solve question immediately. Okay. Just let's derive these terms and we'll solve the equation. We'll solve the questions quickly. Now see what are the terms. So first of all, the time of flight. What do we mean by the time of flight? Let's call it capital T. So as the name, so no definition. Okay, this will be in your mind only. So from the initial position, let's suppose A to the final position, it must have taken some time. That is nothing but the time of flight, right? The second important term here is maximum height. This, see, these three things, between these three things, the whole projectile motion revolves. Okay, so let's suppose the maximum height is h. So what is this h? So this is going to be your maximum height, that is h, right? This is going to be your maximum height where the motion in y direction becomes zero. That is, the velocity in y direction becomes zero, right? Okay, that is what is we call as the maximum height. And there is one more thing, that is your horizontal range. Okay, that will call it as r. That will call it, that is r. So see, obviously, so it is like someone is making a long jump in your schools. This sports is happening, running, and then he jumps like this long jump. Okay, so basically he moves forward in some forward direction also, and from the initial position to the final position, what how much it has moved by horizontally, that is going to be your r. Okay, so this is going to be your R. So now the thing is that we have to find the values of it. And in terms of what? In terms of, we have what? We have our initial velocity, that is u. Okay, this is theta, that is angle of projection. So we'll obviously have some component here. So we'll look into it. So basically we have to find everything in terms of u, theta and g. So I want flight, time of flight, maximum height, horizontal range in terms of u and theta. So what we require, what we need to do, is it clear to you that what is the target, what we want to do here? Yes or no? Give me yes or no. Please answer me. Yeah. Shall I proceed? So it is nothing but beta, you think that you are solving a question. You just think like this way, that you are solving the question. You are solving the question of the motion and the gravity, right? Like for example, let's find the t first. So you have to remember this formula. 2u, you have to remember this formula, 2u sine theta by g anyway, but we'll be deriving it. Okay, so when the motion happens to be from ground to ground in projectile, okay, so you're going to get this t. Okay, so let's try to derive it. So we can derive it by using our equations of motion, because it happens to be the motion under constant gravity. So let's suppose this is A and this is B. Now let's do it. Let's do it. So if I consider the motion from A to B, if I consider the motion from A to B, now we can think in so this is the initial velocity, that is u. This is theta. Okay, so obviously this is u sine theta. This is u cos theta. Okay, now let me consider the motion from A to B. Okay, A to B, and let's suppose not A to B, I'll first do it between A to C. Okay, let's suppose this is point is C, because here we know the velocity is zero. Yeah, very good, she said. Here we know the velocity in the upward direction is zero. So see, let's suppose we are using the y direction thing from A to C. So what is the initial velocity in y direction? Sir, it is u sine theta. Now we are considering from u to C, A to C. What is the final velocity? What is the final velocity? So that is Vy. It is going to be zero. It is going to be zero. Let's suppose from reaching from A to C, it takes t time. It took t time, right? It took t time, right? Okay. Okay. So now what we can do? And acceleration is in y direction. Acceleration is minus g. Okay. Now we can use the equation. What is the equation? So v is equal to u plus a of t. So what is this v? It is 0. What is this u? It is u sine theta. What is this A, so it is minus G, and this is T. So T is going to be U sine theta by G. Okay, did I do something new, beta? Did I do something new? Now from A to C, it is U sine theta. It is U sine theta by G. Okay, okay. So now obviously reaching from C to B also is going to take the same time. So what is going to be the time of flight? Okay, it is going to be 2 times T. So it is going to be 2 times T, that is 2U sine theta by G. Now please tell me if I do something new that we haven't done before. Yes, sir, we have solved multiple questions on this. We have solved so many questions we have done. Na? Sir, stone, balloon, then stone is thrown from the height of the tree. Has fall. So many things we have done. So many things we have done. Isn't it? So many things we have done. Do you agree or not? Please answer me. Okay. Do you agree or not? No, we can do it another way also if you want. Okay, chalo, let's do it in another way. Now let's suppose we are having the motion from A to B. Okay. Now previously, sir, I have considered between A to C, but we can do it anyway. Now again, C in Y direction. Now if I see in the Y direction, and now let me again consider the motion from A to B, right away from A to B, not between the C. Now from A to B, can I say that the initial velocity is u sine theta? Yes, sir, of course, the initial velocity because it is thrown with the velocity of u. So this is u sine theta. Okay, this is so see, it is nothing but the u's. You will get to so this is I consider this projectile motion as the questions of this motion under constant gravity. This is nothing but the questions of it in 2 dimension. Now ui is u sine theta. Okay, ui is u sine theta. What is the acceleration? So it is always minus g. What is the time it took? So it took t time because from A to B that is the complete projectile motion. So it took t time. And what is the displacement in y direction? Can you tell me? What is the displacement in y direction? See, obviously in projectile motion, there will be displacement also in y direction, in x direction, velocity also in x direction, y direction. Bima, I want you to answer this. What is the displacement in y direction? Please tell me, Beta. See, your responses are very important, right? Please answer me. Please, you also can please answer me. I'm very sure you will be able to do it. I have sufficient trust upon you in this. Yeah, please tell me. Both of you. What is going to be the displacement in y direction? So, sir, the displacement in y direction is going to be 0. There is only displacement between A to B. The displacement is not 0. It is there in x direction, but displacement in y direction is 0. Right. Now we can use the formula. So, S is equal to, we know, ut plus half a t square. So, if I use in y direction only, so displacement in y is 0. Displacement initial velocity in y is u sine theta. The time of flight is t minus 1 by 2 g t square minus 1 by 2 g t square, isn't it? Okay. Now from here what we can do, sir, we can write t and this is going to become u sine theta minus g by 2 t is equal to 0. So from here, t is going to become 0 and t is become 2u sine theta by g. Okay, again we are getting the same thing. Again we are getting the same thing, isn't it? T is equal to 0 and t is equal to 2u sine theta by g. So this is going to be the time of flight. Yes or no? Please answer me. Very, very simple, isn't it? Please tell. Did we do anything new other than the motion under constant gravity? Right? In those also we did the same, right? Now similarly we can have the maximum height derived. Let's derive it. Okay, just we are making ourselves more comfortable in motion under constant gravity. That is why I came up with this session. Oh, so you guys are talking in Manipuri again, eh? Yeah, good, no worries. Okay, so maximum height. Okay, what is going to be the maximum height? Let's have it derived. Let's have it derived. Right. Okay. So we have this motion projectile. Let's do it quickly. A, B, C. So maximum height, that means you are supposed to find this edge. You are supposed to find this edge. Okay. Now let's consider again the motion between A to C. And if I consider the motion again A to C, let's suppose this is U and this is going to be obviously U cos theta. I have nothing to do with it. This is going to be U sine theta. This is going to be U sine theta. Okay, U sine theta. So what is going to be Uy? Initially, it is going to be no, 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 no. Please use it. Please use it. Use it. No worries. I have. You are using it. You are helping your friend. Now there is nothing wrong with it, beta. Okay. I was just trying to check whether you are having, you are asking anything. And I'm absolutely fine with it. I'm happy with it that you are helping your friend. No, no problem at all. Please keep using it. Okay. Yeah, you can go on in Manipuri only. No worries, no worries, beta. Okay. The only aim is that ultimately you must get something out of the session. Your time must not be wasted. Right? Okay. That is my purpose. Just that's all. Okay. Now let's come back to the point. So Uy is equal to U sine theta. That is the velocity in initial velocity in y direction is U sine theta. Now let's see what is the final velocity in y direction. So we know it is 0. We know is equal to 0. So now, sir, which equation we have to apply? Sir, A in y direction is minus of g. Let's apply v square is equal to u square plus 2as, right? And I am applying in y direction. Let's write it at y. Okay. Now at C point, what is the velocity? It is 0. Initial velocity is u sine theta whole of a square. Okay. Plus 2, and this is minus g. 2 and minus g, and what is the displacement in y direction at C point? So it is displaced by plus h, isn't it? Sir, how come plus h? Because it is upward from the reference, na? Okay, so we are using the same sign convention, isn't it? At C point, so C point position relative to A, what is the displacement in y? It is plus h, right? Right? Did you get it or not? Yes, sir, absolutely. Now from here we can get this h. So it is going to be u square sine square theta upon 2g. U square sine square theta upon 2g. So that is going to be your h. You need to memorize this also. See, this is very, very frequently and very important topic. So these basic formulas you must memorize. Okay? Because it may take some time for you to derive in the examination and we have to save the some time. Very frequently asked questions are there from projectile motion, so we can do this way. Simple, right? Okay, wonderful. Now we have one more thing. What is the horizontal range? What is the horizontal range? Okay. Now you please derive it. I know that you must have memorized it, but Bima and Shita, you both must please derive it. And Shita, you please help Bima if she needs it. Okay, this is R. Now we want this R. Please go for it. What is the horizontal range? What is the horizontal range? Same way we have to do. This is extremely simple. Please do it. Let's do it. Then, hmm? Wrong answer, she said. What happened? We expect correct answer from you, beta. What about you, Bima? Are you able to do it? See, let me do it now. So it says the horizontal range we have to find. So let's consider the motion from A to B directly. Let us consider the motion directly from A to B, right? I'll do. Don't worry, I'll do now. So now from A to B, when I consider the motion from A to B, so obviously this range is in x direction. So what is the initial velocity? It is u. So this is u, right? This is theta. Okay. So this is u cos theta. So if I consider the x direction, why you are here considering x direction? Because see, range is in x direction. Range is in x direction. So when range is in x direction, beta, when range is in x direction, definitely you are going to see the motion in x direction, isn't it? Definitely the motion you are seeing is in x direction. Okay. Okay. Now how come we can do? So ux is equal to u cos theta and ux is equal to u cos theta. And see, from A to B, we already have the time of flight, that is t. We already have time of flight, that is t, and this is given by 2u sine theta by g, right? We have just derived the formula now, 2u sine theta by g. So what is going to be this r? What is going to be this r? There is no acceleration in x direction, right? So we can simply write s is equal to ut, isn't it? S is equal to ut. Can we write that? Yes or no? Please answer me. Acceleration at x direction is going to become 0, right? This is going to become ut, isn't it? Please answer me. Right? Obviously, sir, it is going to be like this. So, what is the displacement in x direction? So, I'll write Sx here. So, what is the displacement in x direction? So, this is r from initial to final. This is r, right? From initial to final, this is r, right? Okay. Now, from initial to final, since it is r, u is what? U in x direction. I'll write it x direction. So, u cos theta. And what is t? It is 2u sine theta upon g. Okay, so can we write r is equal to u square 2 sine theta cos theta u square 2 sine theta cos theta by g. Is it fine to you, beta? Please answer me. Do you agree to it or not? Please answer me. Yeah, yeah. Okay. Now we also know that the 2 sine theta cos theta, 2 sine theta cos theta is nothing but sine 2 theta. So it is u square sine 2 theta by g. So this is formula of range, isn't it? This is formula of the range, right? Do you agree to it or not? Please answer me. Now see, these three formulas you must memorize. So T is 2u sine theta upon g. H is equal to u square sine square theta upon 2g, and r is equal to u square sine 2 theta u square sine 2 theta upon g. Is that fine? Is that fine? And we know that sine 2 theta is equal to 2 sine theta cos theta. This is more frequently used. Sine 2 theta is equal to 2 sine theta cos theta. So all these formula I recommend that you memorize, although you know how to get them. Yeah, how to get them, but you still memorize these. So let's do some questions now. Basic questions out of it. So let's suppose a ball is thrown with 5 meter per second. See, very, very simple, and I want you to answer it very, very quickly. At angle of projection 37 degree, at angle of projection 37 degree. Now you need to find all these things. Find T, H, and R. So you need to find the time of flight, you need to find the maximum height, and you need to find the range. Please go for it. I'm very sure we can do it. Please go for it. Please go for it. So let's suppose this is the first part of this question. No worries. I'll just add up some more parts. Yeah, let's try it. Let us try this. Very, very simple. Please go for it. Yeah, seems correct. Hmm. Correct only. Very, very simple. No? Just you have to place the things in the formula. So see, a ball is thrown with 5 meters. So we know everything, no? How to see this question. But see, I'll recommend that you in this simple kind of a question you use the formula. Okay. So u is equal to 5 meter per second, u is equal to 5 meter per second, theta is equal to 37. Theta is equal to 37. So it is 2u sine theta by g. Okay. So if at all you forget the formula also in the examination, you can do this question from the basic understanding that we attain in the vector and the gravity. How vector can be used, I'll tell you. Very good, Vima. So this is going to be 2 into 5 upon g. G will consider 10. And what is the sine theta? So 37 degree, no? So 37, so this has to be 3, 4, and 5. This is 37. So what is going to be this sine 37? I'll write sine 37 first. So it will become, see, this is 1 and sine 37 is going to become how much? It is going to become 3 by 5 meter per second. Very good, Vima. Okay, very, very simple. Okay, 3 by 5 is 0.6. Yeah, yeah, you remember this standard triangle. Okay, now we have to find this h. So what is this h, sir? So h is u square sine square theta upon 2g. Now h is equal to u square sine square theta. So initial velocity is 5. So it will become 5 square. Now what is the sine theta? Sine 37. This is going to become 3 by 5. So again 3 by 5 whole of square upon 2 into 10 upon 2 into 10. So what we are getting? So 25 will be cancelled. 9 by 20 meter, whatever it is going to come. No worries. Very good, Bima. Right now we have the range. So range is what? So it is u square 2 sine theta cos theta. Sine 2 theta we don't know, but 2 sine theta cos theta in this way we can do now by g. So u is 5 square. This is 2. What is this sine 37? This is 3 by 5. What is cos 37? This is 4 by 5. Right? This is 4 by 5 upon g, that is 10. Upon g, that is 10. So this will become how much? This is going to become 12 by 5 of meter. Understood? Beta? Very, very simple. Now let me add something to it. Okay. Now please give me, so you need to express, let's see we can do it or not. So we have learned the vectors previously. So express initial and final velocity in vector form. Okay, so you need to get me the initial and final velocity in the vector form. Please go for it. Very, very simple. You need to give me the initial and final velocity in vector. Please go for it. No, complete velocity vector I want now. Complete velocity vector. Do you describe the velocity vector this way in vectors? Don't know? She said. When we have a two-dimensional motion, you can represent a velocity in one go in two dimensions. Isn't it? Very good. Is it initial, final, both, or only initial? Bima, you have to do it also, please. I'm very sure we can do it if we try to. No, no, no problem with that. So this is going to help you in solving the question. We can use the concept of vector, Cartesian, everything. This is why we have learned it. It's initial. Bima, what about you, Vida? Wonderful. See, I'll do it. So in the second part it says that we have to represent the velocity vectors, initial and final, in terms of what? In terms of vector, in the vector format. So see, please observe. Now this is the initial position, guys. So the initial position, it is 5. This is 37. Now when this is 37, obviously this is going to be how much? This is going to be 4 and this is going to be 3. How come, sir? Are from this triangle, this 3 and 4 are the horizontal and vertical component of it only, na? If you see it in the vector form. Okay, so we have to be quick, very quick. Otherwise, one student will lose the 5 cos 37, then cos 37 is 4 by 5. Right? You don't have to do this way. Na? This is a standard. Okay. This is going to be like this. Now, in the end, now what concept we have learned? So this particle will have the constant velocity in x direction throughout, and in the y direction. See, at this point this becomes 0. The velocity becomes 0. Okay. Now, in the final condition, it's going to have the same velocity but in the downward direction, isn't it? This is what we have learned now. This is what we have learned. So if we want to present the initial velocity, it is going to become 4 of I cap plus 3 of j cap, isn't it? Isn't it? Please answer me. How come, sir? How come, sir? So it is going to become 4 of I cap plus 3 of j cap because initial velocity vector. So we can represent any vector when it is in both the Direction, when it is in 2 dimension or 3 dimension, we can represent it by the Cartesian form. How we learned it now? Any vector will have the I component. I component is nothing but the component of that vector in x direction. Y component is going to be nothing but the component of vector of that vector in y direction. Now, similarly, if we see the final one, if we see the final velocity, it is going to be 4 of I cap, because again at this point the velocity is going to be 4 in x direction, and this is 3. 3, it is in minus j direction, so it will be 3i 4i minus 3j cap. Understood, beta? This is how you can get the vector's velocity, isn't it? Isn't it? Okay. Okay. Right. Now afterward they can play with you to anything. Okay. So what is the, if we product the velocity, if we do the cross product or dot product of initial velocity vector, final velocity vector, I think you can deal with all this thing. No need to say. Now let me move to the next one step, next question, which will give you some more insight of it. Shall I? Bima, is it clear to you, Bida? Please do tell me if you feel I'm going very fast. See, because I believe the basics of these topics are already done. We are just, applying the concepts. It's like just like doing the questions of motion under constant velocity and the vectors. Yeah. Shall I move ahead? Please answer me. Shall we proceed? Okay, wonderful. Let's try one more question. Acha, you do realize this fact now that in projectile motion with the transaction, with the trajectory, the theta also changes. We do realize this now. Okay, theta also changes now with each and every path. Hello, Vivek. No. See, there is nothing like that, Bhima. I always tell you. See, since you haven't practiced much, you haven't given the considerable time on this subject. That is why you feel you are weak, right? Right? If any topic you don't know, you will be weak in that. Are you getting my point? Don't feel this way, right? Only the thing is that you have to study. Okay, that's all. So, do you want me to pace it down? Do you want me to slow it down? Just tell me frankly, I will slow it down. No worries. But I can see that you can do some questions. Right? This thing, this concept you understood now. Hello, Prakash. So what we are doing, so the new students, let me tell you that what we are doing here. So my name is Dr. Umashankar Tripathi. Okay, and you see what we are doing here. So we are trying to complete the physics as soon as possible here. Okay, on this channel, and in this direction we have already completed units and measurement chapter, and we are into kinematics. So we have completed motion in straight line till motion under the gravity. Only one topic is left, that is relative velocity in one dimension. I'll be doing it in the next day, tomorrow. And vectors we have completed, which is a part of motion in two dimension or motion in a plane. And one more topic of projectile motion. So I took it today because it is nothing but the application of motion and the gravity. So we are saying we are dealing with some basic questions. Okay. Now, Bima, let's try this question. I'll give you some time. Just tell me where you are getting the obstruction. Okay. She said you also please help her. No, 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 no. Arre, I tell you one thing. See, I don't know biology at all because I haven't read it. Are you getting my point? Any student, see, there is no, all of us have the same brain. Let me tell you this. Okay. Let me tell you this. It's only the matter of practice. When you like practice much, when you give good time to some subject, you are good in that, right? Okay. Are you getting my point? Okay. Like for example, I am a mechanical engineer, you know. So you learn fluid part, properties of bulk material. You just read capillarity, surface tension, and all this. If I start asking you what is boundary layer theory, then you will held up. If I ask you what is the Rayleigh theorem, what is the Froude's number, you know the Reynolds number. There is Froude number also. There is Euler number also. There is Mach number also. Right? What are their uses? Then you will stick to it, right? But what happened? Because what is the reason for that? Because you haven't studied it yet. Simple. When you study something, when you give good time to something, when you practice the question, physics is the easiest subject. It takes the least portion of your brain, I tell you, in NEET examination. See, I salute you guys that how you study biology. Trust me on this. If I read one page of the biology, na, I'll go sleep. You need not to have that. You can write 10 inverse 1 by 4. Right? So, but we need to use that in, question. Okay, then you have to think something. Just try to think of a triangle. I'll give you a hint. You try to think of a triangle. So I think you get 10 theta is equal to 1 by 4. So of that triangle, the perpendicular is 1 and the base is 4, isn't it? Right? So if you ever want to find the sine theta, you can find the hypotenuse. From that, you can get the sine theta in a fraction. Right? But in this case, you don't need that. Right, Bima? So where you are going to apply? No, see, this is very, very simple. I'll tell you. First of all, let me give you some advice here. So all the students who feel weak in physics, you first try to draw the diagram. You first try to interpret the question. Okay, it will improve with time. You will increase your, speed with time. But first of all, let's realize what is asked in the question and how we can approach to it. So a ball is thrown with 50 meter per second at an angle of 37 degrees. So obviously this is going to be the motion. Okay. So let's see that how this data is given. So this is 50 meter per second. Now this is 50 meter per second. This is 37. So this is going to be 40 meter per second. This is going to be 30 meter per second. I hope this is not a problem. Yeah. This is not a problem. Right? And when it was 5, it was 4 and 3. So when it is 50, it is 30 and 40. So what is asked in the question? So we want to have the velocity vector and speed of the ball after 2 seconds. So I don't know where it is after 2 seconds. It could be anywhere. So let me suppose that after 2 seconds, this is the position. It reaches the position, let's suppose C. Okay. So after 2 seconds, the position is C. Let's suppose the position is C. Now, when the position is C, beta, when the position is C, can you tell me what is the horizontal velocity at C? So, sir, in whole projectile motion, the horizontal velocity at C, I write the velocity at C, it's going to be how much? It is going to be 40 meter per second only. Do you agree or not? Please answer me. Right? We have seen this that sir, in projectile motion, the velocity in x direction doesn't change. So the velocity in x direction at this C is going to be 40. Do you agree or not? Because there is no acceleration in x direction simply. Now you only have to worry about the y direction. Now let's use the equation of motion. Okay. See, always go by the basic. Now between A to C, if I apply the equation of motion, I'll write Vy is equal to Uy plus A and T. So T we have, 2 seconds, T we have. So we can have the velocity at Y. So it is going to be how much? So Uy, initial velocity in Y is 30. Acceleration is always minus, so that is minus 10 and it is going to be 2. So what is the velocity in this? Sir, it will be 10 and it came out to be plus. So if it came out to be plus, that means it is upwards. So it hasn't yet reached the maximum height. Now sometimes they can frame you this question like also, like some ball is thrown from some point and please tell whether it has reached the maximum height or not. So now if the velocity is coming out to be positive, given our sign convention, it has not yet reached the final position. Now please tell me, Bima, is it clear till this point? And all the other students also, Prakash, Vivek, everyone who is right now watching me. Yeah? Please tell me yes or no. Right? Very, very simple. Now this is the velocity of C in y direction after 2 seconds. So can I represent this vector in the form of vector? So in the form of vector, I can write this is going to be 40 I cap plus 10 j cap. Do you agree or not? This is going to be velocity at t is equal to 2 seconds. Now this is the velocity vector. So obviously I can get the speed. What is the speed? It is the magnitude of the velocity. So this is going to be 40 square plus 10 square. 40 square plus 10 square, that is going to be root over 500, isn't it? Please answer me. Please answer me. Yeah, meter per second. This is going to be your speed, right? Very, very easy. Now, sir, they are asking us that what is the angle it makes with horizontal. So at C, okay, at C. Now, please observe. See, we can see once we are done with the vector, na, the speed is like anything. Okay, now we have entered, you know, speed track, right? So this is going to be C. So if I am too fast, please do let me know, right? Do let me know. So now this is going to be how much? This is we are not interested in knowing it. So see, this is how much? This is 40 and this is 10. This is 10. So what is going to be this angle, beta? What is going to be this angle? So we have done so much in vector. I hope you realize that this is going to be tan theta is ay upon ax. If any vector is given by axi plus ayj, the tan theta is going to be ay, that is the vertical component upon horizontal component. So what is going to be theta? It is going to be tan inverse 1 by 4, isn't it? Tan inverse 1 by 4. Do you agree or not? Please answer me. Okay. Now if I add up in this question, let's add up. Now further you find displacement vector and displacement also. Let's continue. Displacement vector, find displacement vector and displacement. Please go for it. In this question only we'll further up the concept. Please go for it. Please go for it. Let's see how we can do it. See, all you have to do, beta, in projectile motion, you break the motion into x and y. That's all, right? You apply all the equation in x and y. Please go for it. Give me in the vector form. Bima, I want you to answer this, beta. Please try and answer it. I'm quite sure we can do. Please go for it, beta. Wrong answer, beta. Wrong answer. Please do it again. Sritai. See, we are in no hurry. Let's take some time and solve this. I'm not going to give you many questions in this. Don't worry. We'll see some conceptual question. We can do the questions in the question session. Half day challenge. Right? No, in this after 2 seconds. So you have to find the displacement vector and displacement after 2 seconds. And why would I ask you the displacement? So that is the range only na. At the end of this motion, the displacement in x direction is range, in y direction 0. Would I be asking you that? Why would I ask you that? Are you getting my point? That is obviously range and it will become 0. So you'll apply the formula of range. This is gone. This is all we already have done. So I'm asking you find displacement vector and displacement after 2 seconds. After 2 seconds. Right? Please go for it. Bima, you also please do it. There's nothing to be afraid of. Very simple concept. We have been using equation of motion from quite a time. We have been doing the motion under constant gravity, right? Yeah, perfect. Bhima, you also please do. Hmm. Okay, so how we can do it? See, you have to find the displacement and vector and displacement after 2 seconds. So again, let's visualize this thing. So the motion is taking place like this. From this point, it goes to this point. Okay. Now after 2 seconds, it must have reached some position, and this is C. This is C. This is A. Okay, so we have the initial velocity in x direction and y direction. This is 40 and this is 30. Okay, this is 40 and this is 30. And we have the velocity at c also. We have the velocity at c also. So see how we can do it. So let's break down this equation in x and y direction. Now if I see in x direction, what is going to be the displacement in x direction? Let's call it x. Let's call it x. So it is going to be x is equal to ut plus half at square, right? Ut plus half at square. So a is 0 in x direction. There is no acceleration beta. So it is going to be right away u into t. It is going to be right away u into t. So what is u? It is 40. What is t? It is 2. So this is going to be 80 meters. Okay. Now after 2 seconds, this has moved by the distance of 80 in the horizontal direction. Now let's do it in the y direction. See, very simple. Again, let's apply the same equation. So in the y direction, x, let's call it y. The displacement in x direction. What is the displacement in x direction? This is the displacement in x direction. No? Sorry, this is the displacement in y direction. No? At this point C. Now what is going to be this y? This y is going to be ut plus half a t square. So this is going to be y and it is going to be u. So what is u here in the y direction? So it will, because we are seeing in the y direction, so I'll put it in the y direction. This is going to be 2 plus half. Acceleration is always negative due to gravity. And this is t, that is 2, and this will become 4. This will become 4. So we are going to get y is equal to, so this will become 60. 60 minus 20, that is 40 meter. That is 40 meters. So what is the displacement vector? What is the displacement vector at C? So displacement vector is going to be 80 of I cap. That is the displacement in the direction of X is 80 and it is 40 J cap. Displacement in the direction of Y is 40. Please tell me if it is clear or not. Please answer me. Please tell me yes or no. Hmm? Any doubt in this? Very, very simple. Now, once you have the displacement, you can have the magnitude of the displacement. That is 80 square plus 40 square. Isn't it? Wonderful. Okay, wonderful. So basically, we have seen the basic equations. We have seen the basic formula-wise question. Now let's move to one more concept. Now let's do it yourself. So this is sometimes they ask you in objective out of blue. Like for a let's suppose for a let's consider a question out of it. So for a projectile motion from ground to ground, because it not always happen to be ground to ground. Na? Now you threw the ball and someone is standing on some building. He can catch from there also. Na? Okay, we'll talk about it. Don't worry. That is concept remain the same. Concept more or less is same. Okay, don't worry about it. We'll do that. But today we are dealing with this ground to ground motion. So for a projectile motion from ground to ground, h is equal to r. That is the maximum height and the horizontal range becomes the equal. Now we need to find the angle of projection. Can you do it for me? Find the angle of projection. Can you try it for me? Can you try it for me? Very, very simple. Let's try to do it. Hmm. Very good, Shisha. What about you, Bima? See, this is very, very simple, extremely simple. No? It says that so for a projectile motion from ground to ground, the h and r are the same. So let's do that. So h and r are the same. So h is equal to u square sine square theta. H is equal to u square sine square theta upon 2g. U square sine square theta upon 2g, and r is equal to u square sine 2 theta upon g. Okay, we know their formulas. Okay, so it will become how much? It will become sine square theta. It will become sine square theta, and this is going to be 2. So sine 2 theta is, so I'll take 2 here, and sine 2 theta will become very good as 2 sine theta cos theta. 2 sine theta cos theta, isn't it? Okay, so 1 sine theta will be striked out. It will become tan theta is equal to 4. So theta is equal to tan inverse of 4. Understood, Bida? Understood? So they ask you this directly at time. Now let's try one more question. So I'll be finishing with ground to ground motion today itself. Then in the next session, we'll see the partial projectile one. So for and we'll see the motion of this trajectory also. We'll talk about it. We'll talk about it. But let's first conclude it. So for a projectile motion, From ground to ground, yeah, it was too easy. From projectile motion, so this is the standard. Okay, they ask you a lot of, like many times you will see this question being asked in NEET. So if maximum height is 30 root 3 meter, if maximum height is 30 root 3 meter, and horizontal range is horizontal range is 120 meter. Okay, find initial velocity. Find initial velocity. Today is fast. Is it going too fast? See, it is not that much because concepts are already over now for this particular topic, right? All the concepts are already over. The motion and the gravity is already over. The vectors are already over. Yeah, okay. Please answer it. Forces also is not going to take because the concepts are not there. Na? Concept, not much concept. In forces also, when you will dealing, you will be using the parallelogram law, you will be using the triangle law, you will be using the Lami's theorem, that is nothing but use of sine law. That all we have seen already, isn't it? So now the speed is going to be a little bit more. See, when you are teaching a concept, that takes time. And I see this is my way of teaching. When a concept is taught, I'll take it not very fast. When the concept is taught, then it is like we can do anything afterwards. Right? Please try it. Please try it. Bhima, you please also answer it. Oh, no, no. I want 30, 40, 50, 60 like that. So please do it now. You cannot do it. What about you, Bima? Can you please try doing it? Bima, can anyone, any other? It's very, very simple. What's wrong with this? Huh? Let me do it. Can I do? No, no, no problem. No problem. I'll do. So for a projectile motion from ground to ground, if maximum height is 30 root 3, if maximum height is 30 root 3 meter and horizontal range is 120 meter, find initial velocity and angle of projection. Okay. So what is given? So the maximum height, that is h, is given. So h we know is u square sine square theta, u square sine square theta upon 2g, and horizontal ranges r is 120 meter. R is 120 meter. So r is what? So r is u square sine 2 theta upon g. Now let's process this data. Yeah, let's process this data. What's so difficult in this? So h is 30 root 3 and this is u square. So we have two missing data. We have two variables, so we can easily solve it. No, this is u square sine square theta upon 2g. And what is this r? It is 120 and it is u square. Can I write it as, let's let it be sine 2 theta upon g. Sine 2 theta upon g. Now if I take the ratio of these two, if I take the ratio of these two, did I doing it 30 root 3 upon 120, 30 root 3 upon 120 is equal to u square sine square theta, u square sine square theta. So let's cancel them out now. Why to write it again? Now you see first of all u square will be cancelled out. G will be cancelled out. So we will left with sine square theta upon 2 sine square theta upon 2, and this will become sine 2 theta. Do you agree to it? Yes or no? Yeah, we can just divide. So we have divided, right? Oh, see, I have taken the ratio. That means we have just divided them only. Na? That's it. Yeah. Ha. Now this way, this is okay, isn't it? Now please tell me. Now please tell me. Can I write it as 30 by 120? This is root 3. Now this sine square theta is. Can we write it as sine square theta? And this is going to be 4 because sine 2 theta is 2 sine theta cos theta. So this will become 4. So basically, it is going to become root 3. See, 120 by 4, 30 cancelled out. It will become root 3. And this is going to become tan theta. So theta is going to become 60 degree. What was so difficult here? Why you couldn't do it? Please answer me. What went wrong in this question? What went wrong? Now, in the same way, see what we can do. Now we want to have the u also. So u is 30 root 3. This is going to be 30 root 3 and this is going to be u square sine square theta. So we can put u square. What is sine square theta? So we have sine square 60 degree, right? And upon 2 and g is 10, we know, right? Okay, so we can put, we can keep the value, we can take the value, and from here you do the calculation yourself. We can get the u. Is it okay or not? Please answer me. Please answer me. Is it fine or not? Please answer me. अरे बोलिए ना भाई. Hi Bala, how are you doing, beta? Okay, let's try one more question. Okay. So Bala, we are dealing into the projectile motion. No, no, don't worry, it happens sometime. Okay, let's do one more. Yes, this class is in English only. Actually, this is the English channel. ये English channel है बेटा. तो यहाँ पे ना English में ही हो रहा है जो भी हो रहा है. ठीक है? If you want to study in Hindi, you can come to the. There are other channels of Unacademy as well, where they use bilingual or only Hindi language or mix of it. Okay, but this channel is dedicatedly an English channel, so here we can like use Hindi. All the content is going to be in English only. Okay, okay. So now let's try one more question. So for a projectile motion, okay. So this is English channel only, beta. I think you will be comfortable more in English, right? So I'll tell you briefly what we are going, what is the pattern we are following. I'll just write this question and then I'll tell you. Acha, English is okay for you. Wonderful. Yeah. So basically, that is the idea behind it. And this channel, Unacademy has started because there is no like there may be, but in like our analysis, there is no good English channel of NEET. Yeah, I'll just tell you. So all the students, please solve this question. So let me introduce myself, Balak, to you. So this is basically me. I'm taking PhD from Indian Institute of Technology, Roorkee. These are some more credentials of mine. Okay. So basically, what we are doing at the channel, so we are running biology, we are learning physics, and very soon chemistry is also going to get started. The whole language will be English only. Okay. As far as the physics is concerned, so see, in NEET syllabus, you will find there are first unit, physical word and measurement. That is already completed. I have completed it on this channel. All the videos are available. You can go to the live section. You can find all the videos of units and measurement with question and everything you can do from there. Afterwards, we started the kinematics. So we have done the motion in a straight line till the constant velocity. We have done the motion in a straight line till the constant velocity. Okay, till the constant velocity. Okay, and we already have done the vectors, which is a part of motion in a plane, as you are aware. Okay, so we are now in this session doing the projectile motion, which is again a part of a motion in a plane, which uses the concept of motion under gravity and vectors. Okay, okay, so this way we are trying to complete the physics as fast as possible, right? Okay, this is our approach. Tomorrow I'll be coming up with relative velocity in one dimension, and afterwards we'll go ahead with projectile motion, circular motion. So this is how we are proceeding here. So you can watch the session. You can see if it if it goes with what you find best for you. You can obviously proceed with the channel. Okay, so for that you can subscribe the channel so you get every notification, and also see we are doing question session daily also by the name of 75 days challenge in physics, and biology is starting from tomorrow. The biology sir has some health issues lastly, so basically it was planned to have it started some time back, but it has started after some time. Now it is going to start from tomorrow. I think so, right? So the whole thing is going in a right way. Okay, okay. So you can proceed. Yeah. So we can try this question now. Bima. See, I don't know the answers here. I have vaguely calculated these. Hmm. What about the rest of you? Bima, can you please try solving it, Bida? And Bala, can you do you have any idea of projectile motion, Bida? Very, very simple. So see, this is a very simple question, sir. It says for a projectile motion from ground to ground, horizontal and vertical component of initial velocity are 6 meter per second and 8 meter per second. So what does that mean? So it means that when the motion has started from this point to this point, the motion has started from this point to this point, and the motion happens to be this is going to be u. Okay, this is going to be u, this is like this. Okay, now this says the horizontal component is 6 and this is 8. Okay, this is 6 and 8. So basically this angle, if I assume it to be theta, so we know that horizontal component is u cos theta, that is 6, and vertical component is u sin theta, that is 8. That is 8. So what is going to be the time of flight? So the time of flight t is given by 2u sin theta upon g. Yes, very good, Bima. 2u sin theta upon g. So u sin theta already we have 2 into u sin theta. I'll put directly 2 into 8 by 10. So this is going to be 1.6 second. Very easy, isn't it? Yes, sir. Absolutely. Now, if I see, we have to find the h. So h is what? So h is the u square sin square theta upon g. Okay, upon 2g. Now u square sin square theta, so u sin theta we already have. So u square sin square theta will become u sin theta whole of a square. So it will become 8 square upon 2 into 10. So you can deal with it now. 64 by 20, that is 3.2 meter, right? 3.2 meter, isn't it? Now similarly we have to find the range. What is going to be the range? So range is the u u square sine 2 theta upon g, right? U square sine 2 theta upon g. So can I write it like this? So u square, see, in every question you have to use 2 sine theta cos theta. 2 sine theta cos theta upon g. So obviously this is going to become u square, u square. So can I write it like this? Let me change it. So 2 u sine theta, because it is u square now. So I can take one u with here, one u with here. Okay, upon g. Now u sin theta, u cos theta we already have. That is 2 u sin theta. It is 8. U cos theta, it is 6. U cos theta, it is 6. Right, upon what is g? The g is 10. Okay. Okay. Very, very simple. Very, very simple. Now, what is going to be the angle of projection? This is extremely simple. So, see, right away we can write here. Na? So, tan theta is equal to 4 by, so tan theta will become how much? We take the ratio of it. So, it will become 8 by 6. That is 4 by 3. Now, whenever I see 4 by 3, so this is 4, this is 3, see perpendicular upon base, so this has to be 53 degree because it's our extended triplet, that is 5, 4 and 3. So what is going to be theta? Theta is going to be 53 degree. Please tell me if it is fine or not. Okay. Now, please tell me one thing. Will you be able to deal with such questions of projectile motion, which happens to be from ground to ground using these kind of formulas and all? Will you be able to deal with it? Please answer me. Please answer me. Yeah, you used it. Good. See, one way or another, so one can do u cos theta, u sin theta. They can first find u, then can find theta, then they can apply the formula. It will increase your calculation. You can do that also. That is not a wrong way. What I'm saying that you have u sin theta, you have u cos theta. So initially one can find u, okay, and one can find theta, and then they can use the formulas, and then they can find each and everything. Okay, okay. Okay. Now, shall I proceed, Vida? Shall I proceed? Now, there is one more thing. One more thing. Now, I'll tell you one thing. I'll tell you one thing. So, what is range? What is range? So, one more concept let me give you. Okay. First, I'll tell you what I'm going to give you the concept. So, basically, range. So, range is going to be same. Range is going to be same. Going to be same if a body is projected, if a body is projected at theta and 90 minus theta. Are you going to get it? Please understand this. So see, a body is thrown. So let's suppose there is a ball or something like that. This is thrown at an angle of 30 degree. Let me tell you that. So if it reaches this point, so that is going to be the range. That is going to be the range, right? Now, if you do the calculation and if you see, so this has to be, you memorize this, you please understand this. So if it is thrown at 60 degree, if it is thrown at 60 degree, if it is thrown at 60 degree, it is again going to have the same range. Are you getting my point? So when the angle changes, if this combination of angle is used, you will have the same range. Firstly, this point is clear. What I'm trying to tell you, is it clear? We are going to use it in the question a lot. Hmm? Please answer me. Sir, how come, sir? How come? We can see it mathematically. No, so R is u square sine 2 theta. R is u square sine 2 theta upon g. Now, if I say, let's suppose R1, okay, let's say R1. So I'm using sine 290 minus theta. Sine 290 minus theta upon g. So u square, this will become sine 180 minus 2 theta, 180 minus 2 theta upon g. So R1 is going to become u square, so sine 180 minus 2 theta, so it is going to be sine 2 theta upon g. Now please tell me if it is clear or not. Please answer me. Yeah? Please answer me. Do you agree or not? Please answer me. Okay, so we are going to get the same thing. So R1 and R are equal. R1 and R are equal. So if a body is thrown at an angle of theta and 90 minus theta, we are going to get the same range. We are going to get the same range. So if in a question it says that some ball is thrown or a particle is thrown or something following a projectile path or projectile trajectory, right? Okay, okay. So in that case, at two angles, it has the same range. So that means their range is same. There is angle is theta and 90 minus theta. Clear? Clear? So we can use this information to solve questions quickly. Let's have one. Okay, let's have one here. So we have for two angles, okay, of projection, for two angles of projection, let's suppose for two angle of projection, range is same. For two angle of projection, the range is same, and maximum vertical height, maximum height are different. So obviously range can be same when you change the angle, but height cannot be same, right? It is obviously height cannot be same, right? So it is going to be height are different, and and they are H1 and H2. They are H1 and H2. Okay. Did I did I do some mistake? What you were trying to tell me, she said? Are you trying to tell me something, Bida? No, here you need to find relation between H1, H2, and R. Okay. And R. Okay. So I'll give you something. Acha, acha. You just wanted to write it. Okay, no problem. Sure. Let's try this one. I'm very sure we can do it. Please go for it. Let's see if we can do it or not. Let's try to do that. Let's see if we can do or not. Please do it. Very good, she saying. What about you, Bima? You have changed your solution. Is it? I don't know. I think it's wrong now. I think this is wrong now, Vida. Yeah. I'll be solving now. So very good, Bima. I think you have given the right answer this time. Wonderful. So now for two angles of projection, range is same. Now it is given that for two angle of projection, the range is, I'll just do it. So two angle of projection range is same. So range is same. That means one angle is what? I'll just change the slide. Okay. So one angle is theta, then other is 90 minus theta. I hope this is clear to you. One is theta and one is 90 minus theta. Now both will have the same range. So in this case, R is going to be u square sine 2 theta upon g. Okay. Okay. And for this also, R is going to be u square sine 2 theta upon g. Do you agree? Range is going to be same. Now what about the height, sir? Now what about the height, sir? So H1 is going to be, H1 for this case, it is going to be, we know, u square sine square theta, u square sine square theta upon g. Acha, acha, you got it? No problem, no problem. I'll have to do it, don't worry. So H1 is u square sine square theta upon 2g, and H2 is going to be, in this case, let's call it H2. So it is going to be u square sine square 90 minus theta, sine square 90 minus theta upon 2g. So this H2 obviously is going to become, so I'll write it here, H2 is going to become u square cos square theta upon 2g, u square cos square theta upon 2g. Now we can do it in any way, we can take the ratio, we can do anything. Now if I do it like this, see, I'll have to, so u square sine 2 theta. So can I write it like this? See, I'll just play with this range. So now sine 2 theta, we know it is 2 sine theta cos theta. Now can I write it as this? U cos theta, U sine theta, right? Is it going to be any different? U square sine 2 theta. So what I did, I have written sine 2 theta as 2 sine theta cos theta, and now I have taken 2 outside, then we have U cos theta, U sine theta upon G. Upon G. This is going to be the range, right? Okay. Now this U sine theta. Now please see, U sine theta is, so U cos theta is 2GH2, root 2GH2. And this is going to be root 2GH1, root 2GH1 upon G. Do you agree or not? Acha, acha, Shita, no worries. Okay. Okay, see, I have replaced the value. You can take the ratio also. See the option H1 and H2 are multiplied. You can simply multiply H1 and H2. Something will be cancelled out. You will get some range. So this way also you can do. This way also you can do. I found this, better and time saving. So this is 2 root 2g H2 root 2g H1 upon g, and this is R. Now from here, see what it will become. So root 2 will become 2, and it is 4, and then we have H1, H2. See, G is going to be cancelled out. So this is going to be what option? This is going to be fourth option. Is it fine, Buddha? This is going to be the fourth option. Please tell me if it is fine or not. Yes or no? Yeah? Yeah? Please answer me. Please answer me. Please answer me. Yes or no? Right? Very simple. Bima has given the right answer. Wonderful, beta. Now, one last thing for the day. One last thing for the day. And with this, ground to ground projectile will be finished. Only one thing, trajectory motion will be left. And I'll make one session for that. In the next session, I'll complete equation of trajectory and all. But other than that, all the ground to ground projection, projectile motion is completed. Right? So, one last thing. Okay. So, for projectile motion, projectile motion that happens ground to ground, for projectile motion that happens ground to ground, okay, what is the theta, what is theta for maximum range, what is theta for maximum range, can you tell me that? Yeah, very, very. Please tell me that. Yes. Okay, very good. She said, what about the rest of you? Hmm. Okay, let's do that. So for projectile motion ground to ground, what is theta for maximum range? What is theta for maximum range? So see, I given you something, so that is why we have dealt with, see, all the basic things if you see that we have completed previously, na? Differentiation we have done, integration we have done. So now this is range. So for projectile motion, what is theta for maximum range? So I told you what, that whenever we need to find something like maximum of something, we need to have it differentiated. So if I differentiate it with respect to theta, what we are going to get? So sir, we will be getting u square. So sine 2 theta, it will become 2 cos 2 theta upon g, and we need to put it equal to 0. This is what we have learned in the concept of maxima and minima. Na? Whenever you want to find, whenever you want to find the maximum of any equation, that when it will become maximum, so what you can do, you can always differentiate it with respect to that variable and put it equal to 0. Okay, so when you do that, so you'll like get something like this. So cos 2 theta will become 0, so 2 theta will become 90. Okay, and then theta will become 45. So this happens to be at how much? This happens to be at theta is equal to 45 degrees. So from ground to ground motion, the maximum range will be attained at 45 degrees. Now see, all this can be come into form of question. Like in our projectile motion says that the projectile motion in such a way that a ball is thrown from a point in such a way that it get maximum range. Then immediately you can say that theta becomes 45 degrees. Yes or no? Please answer me. Okay. Okay, so I think the projectile motion, ground to ground motion, you understood all the concepts in it, isn't it? We learned how to derive the formulas, how to, like, I think that this motion is sort of unfolded. It must be having much clarity in your mind. That is why I came up with this session today. Okay, because see, we have done the motion with the gravity. So it is kind of application to this motion under the gravity and some sort of vector. Yeah. Did I do something now? Not cos theta. So see, this is the formula of range, right? U square sine 2 theta by g. Now when we differentiate it, it will become 2 cos 2 theta upon g. So I have differentiated it. Now dr by d theta I have written. Yeah. Okay. I have differentiated it. So see, we understand now that we have the concept of the differentiation. So in differentiation, we have learned a concept of maximum and minima, right? So maxima and minima. So what we have learned, so like I'll just give you a brief. So if y is a function of x and you want to know at when the y will be maximum, so you will differentiate it with respect to x and put it equal to 0. So this will go maximum. This will be y will be maximum at the values of x you get from here. At the values of x you get from differentiating it and putting it equal to 0. Okay. Now here this range is a function of theta. So I have differentiated this range with respect to theta. Then we have put it equal to 0. And afterwards we get the value of this theta. Right? Right? See, minimum it is what is the meaning of minimum? It is 0 only, na? And 90. Right? They don't ask this question. Okay. Right? This is important. Isn't it? Okay. So so I think I think we have done the projectile motion, ground to ground projectile motion quite a depth. We have solved multiple questions and we have done it quick enough, I think. Right? So I'll take it to the next session from this point. So in the next session, I'll come up with the relative velocity in one dimension. And with that topic, the motion in a straight line will be completed. Afterwards, we'll do projectile and circular motion. And your motion in a plane will be completed. And immediately we'll enter into the zone of Newton's law. Okay? Okay? Right? Yeah. Okay? So let's keep it to this point in this session. So all the new students, please do, yeah, not 2 hours here. So please do subscribe to the channel. Please share with your friends so that more students can come and our channel can grow, right? Okay, and more students will come. It will be more competitive. Okay, wonderful. So we'll keep it to this point and have a good day. Let's meet in the next session.